So technically we're being asked to compute the volume of the cone, but in order to do that we need to know the height. So in order to know the height of the cone, we need to recognize that we can treat this like a problem with Pythagorean theorem and like a right triangle. So that's what we're going to do here. I've identified my A, B, and C, and I've substituted those into the Pythagorean theorem. So I have 4 squared plus b squared equals 12 squared. So 16 plus b squared equals 144, and subtracting the 16 on each side gives me b squared equal to 128. So when I take the square root on each side, I'm left with b is equal to the square root of 128. If I want to clean that up a bit, I can. So this is also equal to 8 squared times 2, and so that would then be 8 square root of 2. So I can now use that to calculate the volume. The formula for volume of a cone is 1/3 area of the base times the height of the cone. So we have 1/3. The base is a circle, so we need pi r squared, and in this case the r is going to the radius is 4. So let's go ahead and substitute that in while we're here. So we need that squared. And then we need the height of the entire cone, which we just found, right? So we found that to be 8 square root of 2. When we multiply all of that together, that gives us a total of 128 square root of 2 over 3 pi. Now don't forget, just because, that's a mess, who wants to add anything to that, but we do have to make sure we have the units. So that's going to give us cubic units. So we have 128 square root of 2 over 3 pi cubic units, cubic centimeters, for the volume of the cone.